This is Design Safe Radio, where natural hazards researchers strive to make our society more resilient to everything nature throws at us.
Like, how do you actually get this 33-foot high, with 20 feet of foundation below that, anchoring right on the beach, right on the shoreline? That's got to be quite the feat of logistics and setup, especially compared to, putting the outrigger style tower together. How do you actually install one of these things?
It's again a different beast from the original Florida Coastal Monitoring Program towers you see in orange. Those we can set up in approximately 30 minutes with a trained team, but the Sentinels take several hours, and again, it's the foundation that is the challenge. So when there's a expected landfalling hurricane of significance, something worth putting resources deploying for, we expect local stations might be failing, so we do need to get one of these hardened mobile weather stations there right in the track of the hurricane. We deploy with several trucks worth of equipment. We have one truck hauling our Bobcat skid steer, which can go along the beach without any problem because it's on rubber treads. And then we have another flatbed with all of our Sentinel pieces that we have to assemble on site. And then we have several other trucks towing the original Florida Coastal Monitoring Program, FCMP towers, for nearby deployments. So we end up deploying with several towers, including the Sentinels. For the Sentinels, we start by we get to the site, we unload a bit of the equipment, and then we auger in one of the piles, see if we can reach that depth of 20 feet. Because that's a challenge. Some of the beaches, they're really hard-packed sand, especially the east coast of Florida around Daytona Beach. We found that foundation design was a huge challenge. We spent over a year perfecting the balance between the strength of the pile and the ability to install it in difficult conditions. And we're in a pretty good shape right now. So we drill a test pile. If that's good, then we unload the rest of the equipment, auger in 3 other piles. So now we're about an hour or so in, and then we put a pier cap, an X-frame connecting those 4 piles together. And that has a lot of ability to adjust the tolerances. There's a lot of slop in it because we can't get this pile in the exact right condition. So we slide things around, bolt it tightly, and then we raise up that carbon fiber mast so that the instrument package that's at the top of the carbon fiber mast is that standard 33 feet in the air. And that up there measures the 3 directions of the wind, pressure, temperature, humidity. There's also a tilt sensor because this is a flexible mast. So the mast is going to be deflecting under the wind, under the waves. And we need to correct our measurements so that we can get a horizontal wind speed, even as the structure itself is vibrating under these extreme impact, especially the wave impact loads. And then down at the base, we have an
interesting piece of calculation. Is that mostly post-processing, or is that done in real time on the device? Because that would be some really sophisticated, things to consider.
Right. We do have the data relayed back to us at UF, so we try not to do it that much post-processing locally. But we send that data back, and it's done in real time on the UF side before we post that data and make it available. So that's done live, and then after the event we go back and do QA/QC on the data to make sure there are no anomalies. But we try to make those corrections live on the UF side on our servers.
Wow. So how close are, when you get to something like Helene, how close did you get to where you were intending in terms of hitting that track, having to set this up hours ahead of time versus you only need 30 minutes of warning of the track shift for those orange towers?
Right. Yeah, for Helene, we set up these Sentinel towers about 2 days before landfall, spent 1 day setting up both towers. Because they take a little bit longer to set up, we don't have really the latest and the most updated track right before landfall. So we do our best guess to try to kind of bookend where it could possibly go. And with these Sentinels, we're focused on the storm surge. So it's not just the extreme winds. We want to be where we're going to get the worst storm surge as well. So for Helene, that ended up being setting up in Cedar Key. And then we had to make the decision, do we want to set it up nearby in Steenhatchee, or do we want to go where we expect maybe the track is going to jog to the west? So we ended up setting up a second tower in Matches Sands, south of Tallahassee. And then the following day, we came back and installed our FCMP towers with a group of from IBHS. We set up 3 FCMP towers kind of scattered in between those 2 Sentinels. So we got eye wall passages with the FCMP towers, and we got extreme surge, especially down at Cedar Key with the Sentinel towers. So it's a pretty good spread. And through this NSF MRI program, we plan to build several more Sentinels so that we can don't have to be so conservative with the placement. We can try to get a wider spread, have them a little bit closer together for future deployments.
And for those who aren't familiar, this MRI program is a research instrumentation like upgrade, funding mechanism, if I remember right?
That's correct. Yeah. So through the MRI, we built on this proof of concept Sentinel design. So we're going back and improving design and then building several more updated Sentinel towers that will be deploying in future hurricanes, hopefully starting. Actually, this year, we already had, through the Sentinel MRI, improved the foundation design, made some improvements to the instrumentation, and we did a proof of concept this year through the deployments, and we're going to be building on those and continuing to improve the design in future years.
Great. Yeah, it's been really cool to see this evolve over the past couple of years. I was actually up at OSU when they were testing some of those small scale models, and wow, this is just incredible project that has spanned multiple NHERI facilities and now field deployments. Do you guys also coordinate with Rapid as well when you're doing some of this pre and post event reconnaissance?
Yeah, especially for Helene and then into Milton, we coordinated with the Rapid group, the NHERI and the STEER groups on our deployments because now we're not just wind, we're getting into the surge, the storm surge monitoring, co-located storm surge and wind monitoring. We coordinated with some NHERI groups using Rapid equipment for setting up storm surge measurements. A colleague here at UF, Nina Stark, we worked with her on setting up some stations around Cedar Key. She put some of her surge measurements on the legs of the Sentinel. So we had redundant measurements of storm surge there. So now we have the kind of a broad swath of surge measurements. We have the wind measurements from the Sentinel. So it's a pretty dense understanding of the measurements out during at least Helene. And we took a similar approach in Milton.
That's great. And it's really interesting to see. I mean, we've been talking kind of at the NCO side of or the network coordination office about how to coordinate with all of these different EERs that are now coming online, and each of them has a different type of data that they're interested in. Each has a different focus, and all of them needing to coordinate together with instrumentation and resources like the Sentinel team. What are some of the data you collect? We talked about surge. We talked about wind. What are some of the specific things that you collect, and how do you envision that helping coastal and wind engineers like Dr. Stark and others from those EERs?
Yeah, absolutely. So probably the most important measurements that we collect, or at least the ones that that I deal with personally, are certainly the wind and the wave measurements. The wind measurements we collected at a reference height of 33 feet, and we also collect the surge measurements. We use the rising storm surge or the water measurement to correct our wind measurements because we want to report that as a standard 10-meter wind speed 10 meters above the water level. So as the water rises, we need to take that water measurement and use it to correct our wind speed measurements. And this data we collect in real time. We make it available to local police departments, local emergency responders, the local emergency response management groups, and they use this data to see what the conditions are on the ground without having to send people out into these extreme conditions, and it helps them understand when the conditions are then safe to go back out into. So it's really useful for the local communities. We owe them a debt for letting us come in to their communities in these extreme times, and they work with us to help install this equipment, but then we're more than happy to make that data available to them for their real-time responses. And then we're also working with groups such as NOAA, because they do flyovers of these deployment sites, and we have these surface level measurements that they can then use to calibrate their remote measurement techniques. Use like the SFMR radar. Those measurements get a little bit contaminated and shoaling waves. So if we have that measurement right along the coast, they can use our wind speed measurements and surge measurements to go ahead and calibrate these remote measurement techniques. And then we want to work with the NHERI groups to understand this the relationship between wind and wave and wind and surge. And I think a lot of those collaborations will be coming now that in the future after this event, Helene, and after the events of Helene and Milton. And then the data, and also with FCMP program, we've always made the wind data available, and worked with the steer groups who do the structural post-disaster reconnaissance, because the results of that are much more valuable if you know what the wind speeds were that led to the observed damages.
Thanks for listening to today's episode of Design Safe Radio. Be sure to like and subscribe on whatever platform you happen to be listening to this on. It really helps people find our show. Thanks to our amazing sponsors, the National Science Foundation and the NHERI Network Coordination Office, which is award number 2129782. Big thank you to Marty LaChance, our guest booker and topic researcher extraordinaire, and Raquel Ruiz, who is our video and audio editor. I'm your host and NHERI Facility Scheduling and Operations Coordinator, Dan Zahner. We'll see you in the next episode. Until then, stay resilient.